Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. We're given a transformation that sends a column vector xy to a column vector -yx. Your job is to write it as a 2x2 matrix R, then square that matrix to see what two 90-degree rotations do. The rule x, y maps to -y, x is a classic 90-degree counterclockwise rotation. Let's test it with a sample vector. 2, 1 becomes -1, 2, same length, turned left by a quarter turn. Notice the pattern. We swap the coordinates, and the new x-coordinate gets a minus sign. To build the matrix, we don't need to test every vector. We only need to see where the transformation sends the standard basis vectors e1 and e2. These are the unit step vectors along the axes, perfect for extracting the columns of R. Plug in x equals 1, y equals 0. The output is column vector 0, 1, so the x-axis unit vector rotates onto the positive y-axis. That result becomes column 1 of the matrix. Now plug in x equals 0, y equals 1. The y-axis unit vector rotates onto the negative x-axis. That becomes column 2 of the matrix. Put the image of E1 in the first column and the image of E2 in the second column. This is the 90-degree rotation matrix. Visually, each rotated basis vector literally drops into its column slot. Let's confirm the matrix matches the rule. Multiply it out. The top entry becomes -y, and the bottom entry becomes x. Perfect. So we've nailed the correct R. Now, we apply the same rotation 2 times in a row. Algebraically, that's the matrix product R squared. We multiply these two identical matrices entry by entry. First entry, row 1 dot column 1 gives -1. Next entry, row 1 dot column 2 gives 0. Row 2 dot column 1 gives 0. Row 2 dot column 2 gives -1. So squaring the 90-degree rotation matrix produces -i. It flips every vector to the opposite direction. Geometrically, multiplying by -i sends v to -v, which is exactly a 180-degree rotation around the origin. And in coordinates, xy becomes -x, -y. Key insight: the columns of a transformation matrix are the transformed basis vectors. This matrix rotates every vector by 90 degrees counterclockwise. Applying the 90-degree rotation twice gives a 180-degree rotation. Every vector flips to its opposite. Next up, we'll explore how repeated powers of rotation matrices create cycles and how that connects to eigenvalues and geometry.